Hi, and welcome to runrl. I'm going to submit an example run here where we're going to take a small model and make it really good at guessing chemical molecules based on certain characteristics of the molecule that it gets, which is a really hard task for frontier models. We're going to try to outperform all the frontier models with a very small model using RL. So the first choice we have to make is whether we're just submitting a reward function, which just grades the output, or whether we're going to do a whole environment, which can be multi-turn. We're going to do multi-turn because if a molecule guesses wrong, we want to give it the opportunity to guess again based on the information that it got from its previous guess. For the base model, we're going to go with Quen34b. It's pretty small, it trains quickly, but it's very intelligent, versatile, and good enough to do lots of good RL on. So I think this is definitely on the Pareto frontier of RLable model quality. The prompts are a JSON-L file, where each JSON file contains basically a lot of prompts, maybe some system messages, maybe some user messages, additional information. Let's look at what chemistry looks like. So here we have a system prompt, which is you're a chemistry expert who's trying to guess a drug-like molecule, etc. The user message is just let's begin, because everything's already explained in the system message. And we also have an additional expected result column here, which is the actual molecule that the model is trying to guess. So we're going to actually need to define this environment. I have that pre-written here, which we're just going to load. So essentially the model has 5 guesses to try to guess a smile string, which represents a certain molecule, and we can give it a reward of -1 if the model gives no output. If the model's made too many guesses and got nothing right, it also gets a reward of -1 for that step. But if it does an actual correct or reasonable guess, then we return the tandem mode of similarity between the molecule that it guessed and the actual target molecule. And then we give it a reward depending on how close the guess was, and we give it some additional information in this observation, reward, and done dictionary. So I'm going to go and press run. And we automatically validate the reward function to make sure that everything's valid. And we see here that that didn't work because I forgot to say that we need to install rdkit, which is a chemistry package. So now I can start reinforcement learning, and it'll begin shortly. So it usually takes about 20 minutes to start actually getting the reward go up, stuff like that. So we can come back here later. In the meantime, I can switch to an older run where I run the same thing. And here's kind of what it looks like. The reward basically goes up over time. It always maxes out the generation length in this case, and it costs you about $250 to get a much higher reward than we started out with. And finally, we can deploy the model using the modal API. So in a few minutes, we'll have a modal deployment ready, and then we'll be able to actually talk to the model using an OpenAI compatible API. Thanks. This is most of the features. We also have a hub where people can load and share their models. You can monitor your runs. But yeah, this is the basics of runrl.com. Thank you.